one of the requests from some friends, it's been focusing on the quality of SBOM. And, this is a hard topic, right?
Every device has firmware, which is code to control the hardware. And where does it come from? Who built it? And it's the same with just software supply chains in general. So firmware and software supply chain security is very important. So I'm here with an expert, Alex Matrosov, who who was leading offensive security research at NVIDIA and is one of the co-authors of the book Rootkits and Bootkits by No Sarge Press, and founded Binarly, his own company. So welcome, Alex. I was very curious to learn more about Binarly. Oh, and also we will demo a new open source tool you released, which is SBOM-Tools.
Yeah. All right. Thank you for introduction and thank you for having me. So actually, I indeed spent quite some time in the industry. So started in early 2000s from some bootkit and rootkit research, which is ended up in some famous book on the topic literally called Rootkits and Bootkits. And it's kind of been a conclusion of my work at the time on the most interesting threads. And I get bored on malware research topics and went more on hardware and firmware security. So I work with Intel Corporation when I lead firmware security, also more focused on offensive security side. And later on, NVIDIA invited me to build offensive security team there. So if you remember, it's been quite some time ago, this Nintendo Switch hack happened, right? Mm-hmm. So, and everybody was thinking about game consoles, but the same chip been used in different places. I will not spoil which ones, but it's been actually way broader impact than just gaming consoles. Even Nintendo Switch, it's quite huge market as well. And my team was created specifically to focus on more building the feedback loop between product teams and security mitigations and security technologies NVIDIA been building, and help NVIDIA to kind of understand what matters, what not. And as Halvar said, always raising the bar. You remember this famous meme, mitigator. So industry always want to raise the bar. And I think this makes sense to make exploitation and in general development attack tools more expensive, but it's not solving the problem, right? So one of the reasons why offensive security research at NVIDIA being created, it's more focusing on real value coming from the mitigations, from the technologies being built. And I don't want to spend all the time talking about that, but few things being very thoughtfully embedded. As example, big portion of secure kernel being developed with formal verification on Ada and Spark language. And also NVIDIA being an early adopter of RISC-V. So basically it's been building very thoughtfully security cores inside of the GPUs based on the stack. At the time it's been growing. So basically vendors can influence security mitigations and technologies. And I'm kind of proud what the team been doing on that space as well. Back to the time, we also been given a talk with Adam Zabrodsky at DEF CON about the glitch on some security bit, which can cause a lot of side effects if it will be removed on the paging security. So that's been NVIDIA. And then during the COVID, I was thinking about my career, about spending a lot of time on corporations, fighting with bureaucracy and other things. And okay, I think I always been dreaming to start my own company. And I also see the gaps in the industry which has not been addressed. I see as part of NVIDIA, existing security products don't solve the problem I need to solve at the time in the company. And I decided to start Binarly to actually think more from the perspective deep code inspection, program analysis, because most of the tools been just literally taken the version number, mapped to all vulnerabilities in the world, and give you way much detections you can handle with your teams. But the caveat on that, it's been most of them been false positives, right? Yeah, and you cannot validate it. So basically you need to literally take this binary, do the full reverse engineering and understand understand, and it's no team exists which can handle such a huge volume of detections manually. And this has been the reason why I was thinking the industry needs a different type of automation. Also, NVIDIA been one of the first early adopters, like a CodeQL and SAML at the time before Microsoft and GitHub acquired them. So basically, this semantic detection been impacting, we kind of like get to my brain deeply, because I was thinking it's changing a lot, because like just having like a regex rules, like Coverity or other solutions in the market is doing on AST, abstract syntax tree. I mean, it works. Of course, you can find all these insecure functions, but it doesn't help you to triage them, doesn't really help you with taint analysis, reachability, and many other things. And this has been very interesting when I see the technology which is really work, and the way how CodeQL been built. They've been using data lock approach to kind of like building the symbolic database, and you can create the queries on top of the symbolic database to extract the information. And that was super, super cool. I was like really impressed by this solution. One problem with CodeQL, it's very hard to write these rules. So you literally need to get your brain around the syntaxes of this language, and also have a really kind of like a really good understanding what you're looking for, and how you can really find the bugs in the code to write the right rules. And I think this comes from specifically very deep focus on data lock approach, because data lock approach comes from earlier expert systems time, like a kind of like 70s, 80s, when Prolog programming language being involved, right? So in these queries, it's not really repeating the Prolog, but based also on deep embedded predicates to kind of like a query in logical way, and building these queries. And this is not like a regular person really ready from scratch to write these rules. It's like, try to get just a software developer on Python and give him a Lisp and ask him to write the code. Of course, he will be not immediately to develop any type of meaningful program, because it takes time to adopt. It's a different, not just a different programming language, it's completely different paradigm. And this has been kind of a caveat around the CodeQL. It is really time of adoption. Afterwards, we have also SamGraph, which is kind of like not really regex, but kind of, and also it's not as powerful as CodeQL. It's something on the middle between like just a AST parsers and this complex thing which is CodeQL stand for. But this is helps like majority of the people write these detection rules easily, and it's basically all the success it's around that. But this is about the source code analysis, right? And when I started Binarly, I was thinking we need to build something which is way different when we're focusing on the binary level. And of course, we have Yara detection rules. Everybody loved them, but Yara, it's really good for finding like indicators of malicious code presence or something like that. So, but it's never been built for vulnerability detection. So basically, if you find in the vulnerability, like, of course, sometimes it's just one small thing, but in most of the cases, you need to detect one thing. Maybe it's like some condition on one place, then it's something bit presence in different place, and actual trigger in completely different place. So it's connecting all this tree. It's creating like a gigantic Yara rule. Nobody want to read, understand, or even like after a week, you don't want to touch it. So this is not something sustainable. So basically, the technology not been built for that, and it's not effective for such detections. We start thinking how we can actually create more meaningful semantic level detections when we just not go on raw bytes, like basically what Yara does, and making the detection when we lift the code something to the intermediate representation. And we created our own SSA form when we can apply some logic rules and detections. And basically, we have also taint analysis and reachability analysis out of the box. And this has been very powerful on the binary level. Why? Using intermediate representation, it's basically when you get a canonical representation. Of course, same bug on different platforms also can differ, right? Or like even with different compilers when you
Right.
recompile, or
Yeah.
with different
Right.
optimization flags. But you need to understand the semantics, which has help you to create some different conditions, or basically create the detections which will be close to zero false positives.
And
So
in
it's
this case, the input you're taking, it's the binary itself, not the source code of the program.
Yeah, exactly. It's a binary itself. So,
Mm-hmm.
and if you think about, I also want to pivot a bit on the software supply chain side of this
Yeah.
problem. So
Mm-hmm.
basically, nowadays, like 90% of the code not written by the company, it's
Right.
combined together from the frameworks,
Yeah.
libraries, and components you're getting from the third parties, right? And in the end, like basically, if you have large symbolic database of OSS components, so you could actually extract a lot of meaningful data from binary itself.
Mm-hmm.
Also, program analysis as a field being developed way far from comparing to what we have at the beginning of 2000s. Like basically when first time I start I've been introduced to symbolic execution back to probably like a 2006.
Mm-hmm.
So basically, like I was like, wow, that's magic. Like when you can validate the conditions and debugger can pass some of the conditions automatically and basically get to the place where something interesting is happening. And also, like later on we have fuzzing, like, and this has been giving you like and keep giving a lot of crashes, but you need to triage them at the end.
Yeah.
So and not every crash it is actual exploitable vulnerability or security bug. So I think like from that perspective, like when we start developing this Vulhan technology for detecting semantically those vulnerabilities, the main reason was exactly to kind of like create the context, and with this context detect and reason the detections on the binary level. This
Mm-hmm.
has been always, a dream for many researchers. I knew in the past Dynamics, Thomas Doolin and his team been working a lot. And by the way, he's also advisor and investor in Binarly.
Oh, nice,
So
nice.
yeah, a lot on this space. So, and basically it's why Google actually acquired them, because of multiple technologies they built. I mean, like BinDiff, it's still way to go for comparing the binaries, and I still using this
Yeah.
tool. And Thomas always joking, like about this tool been built like 15 years ago and it's still useful, like
Yeah. Right.
yeah, but he said he's excited, but also in the same time not, because industry not really progressing. And one of the things we've been also deeply thinking about is how we can evolve the code similarity search. And it's where all this semantic context we've been building, it's actually been helping us to kind of like create more meaningful knowledge around the code base, and basically create some sort of queries and search or embeddings with machine learning model. And I think these technologies and these ideas and mindset, it is a way to go to solve the software supply chain problems and vulnerability detection, because specifically with current artificial intelligence development, like last week we have this call from Anthropic when they said they stepping in the developing and cybersecurity products, right?
Yeah.
And I was like, I was excited about that, and I can tell you why, because one of the reason I was excited, I could see the way when like a really simple ways of detections, like software composition analysis tools, can be wipe coded in, I don't know, like probably a few hours, maybe a few
Sure.
days. It depends on complexity one you want to build, but like in the end, it's not a know-how anymore, and the real products with real IPs will be differentiated, because something you cannot replicate easily, which is requires domain-specific knowledge, this type of the companies will be succeeding. And this is exciting time for any researchers as well. I believe like starting the company, it's a great point of time is now, because
Mm-hmm.
first we have this breaking truth development on the coding models, right? I
Mm-hmm.
mean, Opus with Claude Code, it surprised me a lot. I've been
Yeah, I
very,
like it.
I don't want to pivot from one topic to another,
Mm-hmm.
but I can't stop on this topic because it's really excite me. A year ago, I've
Mm-hmm.
been arguing on Twitter about like, it's no way LLM will find meaningful
No, really.
vulnerabilities. Yeah, exactly. Because honestly, I try it, right?
Yeah.
So, and this comes from my personal experience. And at the time, they really failed. I mean, of course,
Yeah.
like they will be scream on the mem copy, but if it's not obvious mem copy,
Right.
which is exploitable,
Mm-hmm.
it was not really reasoned on the code the way it can actually follow deeply
Mm-hmm.
the path of something and triage the vulnerability on the source code level.
Mm-hmm.
And when basically midsummer, beginning of the fall last year, I tried like a more like a recent models, and I was surprised because exactly like about a year ago from that time, it cannot spoil the vulnerabilities we've been discovering on the UEFI firmware level. The reason is
Yeah.
why, because of domain-specific knowledge. Even the bug
Mm-hmm.
was super simple, double misuse of get variable, which is like super straightforward vulnerability. It's no way how you can not find it. So, but because of the domain-specific knowledge, it's been not finding these problems. Basically, last fall, it's been an eye-opening moment when exactly the same prompt, it's been giving me the answer with way more detailed advisory I was writing myself.
Mm-hmm. Mm-hmm. Nice.
And I was like, whoa, that's great. I mean, of course, it's maybe they just browse Binarly knowledge base with all vulnerabilities because it's public on GitHub with markdown files. I don't know, but in the end, like it's been super effective on
Yeah.
detecting these things on the source code. And this has been kind of for me and eye-opening momentum when I see the shift is happening.
Mm-hmm.
Shift from the perspective like AI, it's different from other technologies because evolution it's basically proceeding way faster than on any other technology areas. I mean, like basically in 1 year, even programming language is not evolving that fast. And I think like of course, it ties a lot to the data, how the data is processed, and basically building some core domains where this model's been having the focus areas to improve analysis and reasoning and contextualization. But I think like coming back to the topic I started with, I think for the potential security founders or for the people who building something right now, it's super exciting time because they can start adopting, like first, you can scale your prototyping minimum
Mm-hmm.
valuable product way faster than I started in 2021. I mean, I mean, maybe not exactly, but even one person right now is a team.
Yeah.
Uh,
Yeah. Mm-hmm.
Another eye-opening momentum was like when I was like, it's no good tools for SBOM browsing, and like, what if I just for fun start prompting with Cloud Code end of December last year, and start building the tool I want to be. And like, I was like, okay, I don't want a UI tool, like fancy UI tool. I want to something simple in a terminal interface or maybe command line. And I just start kind of iterating. And of course, like I knew what exactly I want, and I already knew how to prompt,
Yeah.
write like a chain prompts and contextualize the Claude. And, I was impressed what I get in the first iteration. And of course, I keep iterating and I keep using Claude. But this tool, like I built, maybe spending in total, maybe like 4 hours, and just like in between the meetings or when I have time just for fun. And the value you are getting from this 4 hours of prompting or just sometimes waiting when the, the code get generated, it's impressed me a lot. And I think like right now, the time is really when one person can become a team. You can prototype something. You can basically already have proof of your view on the technology, or at least build something for understanding of your potential customers or investors, and or the like people you want to convince to join you as a team, right? And I think from that perspective, it's a really interesting time. I believe the software development in 2026, by the end of 2026, it will be very different from we even have it now.
Hmm.
But I think uh, you know if you remember like a promise on Java or .NET or all these technologies, when they try to build the framework, when a lot of basic blocks will be reusable, and we just building from these reusable basic blocks, basically kind of like a logic we want from the application or software. Like from current AI-driven development, AI can build the basic blocks which does not exist, or reuse existing basic blocks, and AI can help you to shape your reasoning and logic for this application, fit to these basic blocks. I think this is a very different paradigm we have before, because I see a lot of skepticism. I mean, I'm in general like the new technologies, but I've been skeptic as well. It's not like I'm too excited. I still watching what is going on and what's happening, but I see the progress and evolution, and it's already impressed me.
Nice, nice. Wow. Yeah, everything you just said was like a giant shot of insight, like right into my brain. I especially love it because it's from the perspective of a founder, someone like with their own company. Um, One thing I wanted to talk about, the idea of like binarily. I think it's a interesting idea, the shift towards shift right rather than shift left, like moving more towards runtime. And I think that's always been super interesting to me, because what's in runtime is ultimately what I actually care about, right? What actually matters. And when we analyze the code is one thing, but what's actually running in runtime could be completely different. Like, is this actually this
Exactly.
code that I'm running in runtime? And there's also like dependencies, as you said, like libraries, all of that's contributing to what's actually in runtime. Now, the challenge with runtime has always been to me that it's just like extremely difficult for me to do any sort of runtime or like binary analysis in general. Like, as someone on a blue team or security engineering, like I'm not gonna spend my time like reverse engineering every single binary. So it was completely infeasible. And I like your perspective. Like, nowadays, it looks like now we're approaching a time where we have enough tooling, with machine learning and every that, we are approaching capabilities where we can actually do binary analysis to help security teams.
Yeah, I think this is a great question. I think also different solutions built for different things, and we can see a lot of solutions and happening right now with eBPF, like automation on top of eBPF, and
Mm,
that's works. But it's not like we try to replace dynamic analysis. But I think having dynamic analysis at scale, it's hard, because
yeah,
it's taking just more time. And when you need to analyze like a few thousands of binaries, how long it will be
right,
take to finish this analysis, then you start doing the compromises, and it's where the gaps on detection start happening,
right.
and the solution will be decreasing the value. Why we're not focusing it? I mean, and it's not like we're not really focusing on dynamic analysis. We have some sort of emulation to reconstruct some of the things, because it's hard to just do in pure static. But I think for scale analysis, it requires a different approach, when basically you can prove some of the things presence with reachability analysis, but reachability analysis can be proven in static analysis as
Hmm.
well. So
Hmm.
where you basically can prove the trigger is reachable, and it will be in runtime. But of course, when it comes to the environment of operating system and others, you don't have a knowledge about this environment when you're doing the static analysis. You can build some assumptions, but you don't have exact knowledge when this binary will
Right.
be executed, and maybe
Hmm.
runtime environment will be influencing specifically. And this is a different story. In this case, both solutions have a place to be. They just build for different type of problems. And I think one of the reasons why we've been building exactly that way, imagine the situation when you are Nvidia or like a other big company, large company, which is like have hundreds of product lines, and you have vulnerability, and you need to understand, because it's massive reuse of this code base between the product lines. As example, like any hardware company like Dell, HP, and others, they have like 100 plus different laptops lines, and of course, like they built on top of the same code base. If you
Mm-hmm.
find the vulnerability, you need to understand how many products are impacted by this
Mm-hmm.
vulnerability, or
Yeah.
third-party vendor from your supply chain report your vulnerability, and you need to discover these patterns inside of that. And you don't have access to the source code from this vendor. What you will do,
Right.
right? So
Yeah.
you just like, oh, it's present, it's impacted, but it's not really a good approach. So basically, of course, you can do that. And apply patches, but if you have like hundreds of places you need to make it happen, you need the priorities to be set. You need basically empower your team with the right tooling and prioritization.
Yeah.
Otherwise,
Nice one.
like they
Mm-hmm.
will be just blindly go in some directions, which not maybe the right directions to go. Um,
Nice.
and I think like application security, software supply chain security, and all these buzzwords around the program analysis tooling right now, creating new way of like how product security teams are behave. And for me, an eye-opening momentum was from we disclosed at Binarly 1,000 plus vulnerabilities, and sometimes when you're working with a vendor, you expect they have security team or at least few people to work on that. And some of the hardware vendors, which is like a hardware used in the data centers of the companies like Meta and others, they don't have security team. Literally on the PCORT email, the guy from marketing is sitting and replying these emails.
Mm.
This is blowing my mind. So, I understand if they don't have resources or money, but this company is like super profitable. They just don't want to overspend. I understand they need to keep up the price, and security, it's always a compromise because like you're investing, and it's increasing the price of the product, but not really visible for your customers. And from that side, because I'm founder of the business as well, I understand. But from other side, as a researcher, I don't, because like this is kind of a open doors for the attackers, and we relying so much on this artificial intelligence infrastructure now, and just blindly trust everything what executes on the hardware or like a
Mm-hmm.
firmware layer. It's a mistake from my perspective, because if you don't understand your stack, you basically blindly trust, and you just have a risk you don't know about.
Mm-hmm. Yeah, that's really good. And I guess related, both on the hardware level, we have like many different like firmwares running for like multiple things on the device, and the same in a binary. Like given a binary, once you like check what's in it, there's code coming from many different places, right? And so I assume that's like one of the challenges to the teams like looking at results is like some things are under their control and they can map back to like their own code base, but not everything. Some things are from third party vendors. So what's like the range of like all of the different things they see, and like how do you handle that?
Well, this is a interesting question, and it's actually a hard one, because you know um, it's like too many different things, right?
Right.
And also, as example, if we're talking about real-time operating system, it's not many, but like they are different.
Mm-hmm.
If we're talking about like a FreeRTOS, it's one thing. If we go into QNX or something else, it's a different thing. And basically supporting all of them. If one vendor will say, I support everything, they're lying. So I think like it's impossible because you always need to keep up with all the changes. You need to have a team or a few people to watch these changes. We always play from the perspective what our customers is using, and basically if we have some resources we can apply for monitoring these particular binaries or ecosystems, we proceeding forward. If not, I mean, like we are a small team. We can't just keep aiding everything. So, like, and I believe like from the perspective of ecosystem, it is a problem because first, all these proprietary ecosystems, to understand them and create a meaningful detections, it requires time. Imagine even based management controllers. Of course, we have OpenBMC, which is open source, great, but we have like iDRAG from HP, and we have like ILO from HP and iDRAG from Dell. So, and I think like we have so many different modifications even on their own product lines, and in the end, you get like a part of these binaries encrypted, so you don't have encryption keys. How you will be analyze it? Of course, you can like go and hack their root of trust, but it's like, what's the reason for that? And I think like this has been my understanding of the problem before we found Pkfile. One of the vulnerabilities we discovered when encryption key being reused for all the product lines in the world from one vendor, and it's leaked, and then basically it's been impacting the secure boot on all major vendors besides Apple, of course, because they not using third-party firmware, they developing themselves. Smart, because they can keep consistency of their stack, and they have resources for it. But I think like that's been a huge problem for the entire industry when we discover. And in this case, I think maybe if you will be lucky from the researcher perspective and you extract one key, you can encrypt all these BMCs in the world, but who knows? Or at least from one vendor. But I don't think that's the way how industry should work, and security by obscurity really doesn't. I knew some vendors actually in their firmwares even obfuscate the function names. And when I've been talking with their security team, I said, guys, it's actually create more problems for you than actually advantage for protecting you from the attacker. And exactly, because for me, it doesn't matter how function is called. If it is a bug, it is a bug.
Nice. And I was just curious from your perspective, like you have to support like different architectures, different operating systems. Like what do you usually go for? Is it like mostly like Linux, mostly ARM? Like what's the most common, I guess?
I mean, it depends on the firmware. We support like ARM 64, 30 bits, like a low power microcontrollers, and x86 bits, and like a x86 ecosystem in whole. I think like from like one another reason why we start building intermediate representation, basically to kind of like easy adopt the detections and add new ecosystems. It takes time, I would say, but majority from our customers, it is RISC-V, ARM, and x86, and we don't support others at the moment, but we didn't have any request because this is the majority what our customers use. I think maybe if we will get to some certain new markets, maybe we'll be at MIPS. It's another one which we've been thinking about, but it's not an easy one from the perspective of migrate all the detections, because it's very different from ARM. So I would say
Nice.
it's
That's
take
really
time
cool.
for adoption. Yeah.
And I'm just curious from the things you do find, like how many of the findings are actually fixable, whereas like so some of them are like no, like your whole architecture is wrong, the whole design is wrong, you have to start from scratch.
I mean, the lesson I learned, like when you are a researcher from outside, you don't see a lot of things which is inside. And when I've been driving and working at product security at NVIDIA, again, like when you get report from outside, basically the person really don't see everything, right? And sometimes he sees the impact like that, but the real impact could be way bigger, and you need to fix way more places to actually mitigate this bug. I think I think like basically helping and proposing the fixes, it's kind of an advice for researchers. When you propose a fix for the vendor, I mean, the vendor definitely need to take this to consideration, but it doesn't mean this fix it's really appropriate to fix the problem for particular vulnerability, because it can be not limited or don't applies to the entire scope of the problem. And but I can give you some examples like in 2022, we report vulnerability which has been fixed 7 times. So from one of the independent BIOS developers vendors, which is code reused in many different places on by the vendors like Dell, HP, and many others. Another example, most recent one from our DistriCon talk in January, it is a Supermicro based management controller. So first time bug being reported, basically it is a bypass of their root of trust. That's mean you can basically and bypass of root of trust and verification. So you can malform firmware update, and it can be correctly applied to the base management controller, and basically boot and bypass all the mitigations. So the cool vulnerability found by NVIDIA Offensive Research, proud of the team, and we basically, because we're working on this space, we pick up these vulnerabilities after they disclosed publicly and start looking to add the detections, because some of the customers been asking for it.
Oh,
And
nice.
we like, wait a minute, it's not fixed properly.
Oh.
And we report another 2 vulnerabilities. We presented them at LabsCon last year in September. And then Supermicro applied the fixes, and we found another ones. So basically, it's been 3 times when they try to fix the same vulnerabilities. But I would say, bless you, I would say working with closely with the security team and from the vendor side, and like they've been open for collaboration. And when we start basically give them advices, they start listening. And in the end, like we told them, guys, we don't have a reason to populate the CVs. We have enough. So yeah, if you want, send us your fixes to validate early. Basically, like we can, if we find something, we'll let you know. And basically, this collaboration helped them to fix these vulnerabilities properly. And it's been kind of a courtesy, because it's not our customer, we don't get any money, and basically just a goodwill, because we see how this problem can scale, and we see how dangerous this type of the vulnerabilities are. Basically, it gives so much power for the attacker to persist on base management controller. If you persist on base management controller, you can change the system firmware. Even more, if you have an FPGA and ASIC on the board, you can even influence there as well. And sometimes base management controller can bypass like a verification process and flash to spy flash directly some firmware update, which is basically could bypass some of the security mitigations as well.
Wow.
And this is a huge problem. I can talk on the firmware problems probably for the next 2 hours. So yeah.
No, I love that it's not just about finding and dropping the vulnerabilities, it's also the relationship with the manufacturer or the vendor about like just how to fix it long term. That's really cool to see.
Like myself, for me, it's been a learning curve. When basically I've been finding my early bugs in early 2000s, I was brutal with the vendors, but it doesn't really work well from the perspective. Vendors get pissed and they don't really want to work with you as a researcher.
They want to fight you,
yeah, exactly. And it doesn't benefit anyone. From that perspective, basically, when I work already myself on the vendor side, I understand the pain, I understand the problems, and I understand also why sometimes vendors not really communicative too much on their side of the PCERT, because sometimes researchers can share on their blogs the entire communication with the vendor, and it's like a not good actually approach, because if you want to collaborate with the vendor, like you need to kind of like have certain, like, I mean, sometimes they push for NDA. I'm not sure like if for researchers sign a lot of NDAs, it's a good idea. But basically, of course, if you work with this partner or customer, it's a different story. But if it is just outside report, so probably you don't want it. But it's kind of like a gentleman agreement when you don't want to also abuse the openness from the vendors in the bad way. So one of the good things I think CertCC, Carnegie Mellon Cert, created, it's program called WINS, or like a service called WINS, when you can report to the CertCC your vulnerabilities, and they can help you to communicate on your behalf with a vendor. It's different from bug bounties, by the way, because when you report vulnerability through the bug bounty, you're already not own vulnerability anymore, like a bug bounty vendor of this vulnerability. And basically, like if you sign any agreements or get paid, so like, forget about this bug, it's not yours anymore. So I think from researcher perspective, I would say early in my career, I've been focusing on vulnerabilities and counting like how many CVs, but it doesn't really matter. I think what really matters, how much impact you are or influence you're creating and helping to fix these problems. And basically like, of course, like POCs help the vendor to fix and understand the problem. But again, if you communicate in the right way, you learn more about the problem, and also you help to the vendor to fix these problems properly. I think this is kind of a win-win situation. But I wish it will be more bug bounty programs as well on the firmware space, which will be help to facilitate and secure these topics, because it's really almost close to zero. Like funny part, we've been participating to Intel NUC by bug bounty program when it's been exist, because NUC it's not Intel product anymore. So
I didn't know that.
and Intel actually sold this product line, I believe, to Asus. So if you will be buying NUC, it's not coming from Intel anymore. It's coming from vendor which is not really cares about security. So and basically, like a funny part, we disclosed quite a lot vulnerabilities to Intel. Good thing Intel PCert, most of them publish as an advisories, but also we gain our first capital when we've been early days of Binarly. This is one of our sources of funding. It's been basically finding these problems at bug bounties.
Wow. Very, very cool. Very good perspective. Also shifting a little bit from just like sending CVEs to collecting CVEs to like actually working on fixes. Okay, is there anything you want to mention, or should we get into the demos?
Yeah, let's get to the demo and also to the purpose of building SBOM-Tools.
So this is the tool that you're going to demo. First of all, it's an absolutely beautiful TUI. I guess to explain what it is, first we need to figure out what is an SBOM.
That's a great question. Like software bill of materials, it came up as a concept in 2021. And I think like the major idea was great. So basically, we need to have some list of ingredients for the software. I love it. But execution of the time, it's been kind of lame. So the vendors start building like a gigantic XMLs or like a JSONs, but it doesn't really work well for the industry. I think really step up from the crowd the format called CycloneDX, where it's completely open sourced, and a lot of security practitioners is involved in developing this format. Also, entire OWASP community as well, which is helpful. So basically, it's embedded a lot of useful pieces of information, and in the end, it's not just became the list of ingredients of all the components, you can ingest additional data about vulnerabilities, about cryptographic materials, etc. This is actually what motivated me to develop this tool, because if you extract all the information to software bill of materials correctly and ingest additional data, it became a very powerful report. But the problem is it's no tools to help you navigate effectively on all this data. So basically it's like a raw JSON with a lot of a machine readable identifiers, which is not super helpful to read it. And basically it's hard to navigate, nobody looking on it. And this has been a sad momentum, because if you have the directory of software bill of materials from the same products from incremental builds, if you just run diff on SBOM over the time, you can see kind of a supply chain report, how your supply chain is evolving. One kind of a point with star, your SBOM need to be correct. It's need to have a useful data, right? Because the tool is not producing an SBOM, it's extracting data from SBOM and representing this data in a useful way. And I think from that perspective, I really see the value when an SBOM could became some sort of a source of truth, what's inside, right? So this is this tool, I mentioned it earlier on podcast, I built in my holidays time, try Cloud Code in something useful way when I can build something from scratch, and it will be useful for me and maybe potentially for security community. So this SBOM is extracted from binary, as you can see. BMC, it's a base management controller from Supermicro. So basically, it's not 100% accurate, but it's contain a lot of data. As example, we can go to the components and we can see and group them in different way. If we basically use grouping, so we can see based on the license, based on type of the files or vulnerabilities. So basically we can see all the binaries or components inside. So this is kind of useful data. And
here, just for context, for those who have never created an SBOM before, here we're using there are tools out there that generate this SBOM for us and into the Cyclone DX format or SPDX, and then I download it locally and I run this tool and load that file in there, and this is showing me the contents basically of the file.
Yeah, exactly. I mean, honestly, Binarly has a free service called fwhunt.run, RUN. So basically, you can go there and generate from any UEFI firmware an SBOM for free and try with an SBOM-Tools. But in general, if you're dealing with an open source software, you can use tools like Sift or some others, which is produce an SBOM from the source code, and it's quite useful tools, and they are great. The problem is they don't help you navigate on this data, and the whole reason of creation of SBOM-Tools, it's been exactly that. So I mean, creating an SBOM from the source code, it's not a challenge. Creating an SBOM from binary or software package, it is a challenge, because you don't have an access to the source code. You need to navigate and understand you extracting all the data correctly, and this data is complete, or at least close to be complete. I think this is a major challenge right now. Also, funny part, when SBOM became mandatory for the vendors to share, some of the firmware vendors, when they have some offshore development in Taiwan or India, so what happened, they basically mandatory ask their product teams to build an SBOMs, but basically it's not been tooling for firmware to basically build an SBOMs. People been typing an SBOMs in text files. I'm not kidding.
That's crazy.
And yeah, you've been finding the crazy typos and wait a minute, it's not produced by machine, by the code. It's produced by people. And this has been quite crazy. Or sometimes they give you an old SBOM, which is not relevant to the code base at all. And this has been crazy. I think having an attention to what you're getting from the vendors on software bill of materials side, it makes sense. But again, if it is a gigantic JSON file, how you can navigate, how you can understand the data is correct, this is the whole reason why this tool being created, and it's open sourced. If you have any feedback or feature request, you are welcome. If you want to contribute, send me a pull request. I will be happy to review and apply, because again, it's great to have my buddy Claude to helping me, but I think help from the community will be better. Let me come back to the tool. I think another one, it is vulnerabilities tab, where you basically can browse or vulnerabilities which is present, and CVEs. This is helpful as well. I think licenses, it's pretty powerful, because I always don't remember which properties on which license and how they differ, like a GPL 1.0 or 3.0, right?
Yeah.
But
That's really useful. I'm curious, for the vulnerabilities, where are you populating those from?
Oh, this is present on SBOM. This is vulnerabilities being ingested, but the SBOM-Tools had an ability to ingest some of the data. So basically, we are ingesting data from OSV, Google project. So basically, and from GitHub. Also, it's another format from CycloneDX called VEX, which is vulnerability exchange format, and you can ingest from VEX data to SBOM-Tools or SBOM, and basically have a more meaningful report. But again, our goal, it's not like I'm not building a tool which will be ingesting a lot of data. The goal is just help to navigate on the data, because I want to keep it simple. Like I will not collect any telemetry data, and as much as more it will be basically requires an API keys and working with third-party services, it will become more complicated for people to use, and I just don't want to overcomplicate the purpose of the tool on navigating on the data. So maybe with the time it could change, or like it will be a different tool, like a ingest tool or whatever. So in other dependencies, it's also quite cool. So basically you can see all the components, which is dependencies, even like as example, you can see GCC, probably the compiler is used, or like a glibc related to this version of the compiler. So I think like this is just a lot. So, I mean, like, I'm still working on some additional data represented on this screen, but it's already quite useful. So you can also group and in the same way. What is useful as well, you can see some files which is related to cryptographic materials, right? So, and you can catch there, even like it's not a software cryptographic bill of materials, you're just catching them as the files on the file system. So, and this is pretty much cool on that side. I think like one of the requests from some friends, it's been focusing on the quality of SBOM. And, like, this is a hard topic, right? So, but I'm working on the blog post where I will be describe the quality criteria measurement, because I believe like right now, nobody actually measure, and we need to understand as an industry what good is, right? So, and how we can understand if your SBOM is not good, you can trust it. So obviously, and but we need to define what is good first.
That's a very interesting topic. I mean, that's the whole project in itself, like assessing like the quality and giving it a number to each SBOM.
Exactly. I think like and it's no good independent, not vendor agnostic studies on that. Maybe James, previous guest on your podcast, and his company want to do it. It will be fun to have it. So in my opinion, it's someone vendor agnostic, independent need to produce this data. I'm happy to help, but I'm biased as founder of the company. So I think like from that perspective, maybe you want to actually make the study happen, and I'm happy to participate on podcasts to go over it and discuss. And another thing, it was a compliance, and I think like compliance standards, it's different, right? We have like a CRA, we have like different phases actually of CRA. We have NIST, we have FDA, etc. But nobody providing you useful data, what these problems are. Does this most of this compliance failures, it's basically information not present or information present in the not way how specification recommended to produce this data, right? And I think like it's very important to understand what the compliance requirements are and how you can actually help companies to navigate on that. And this has been also very helpful for a lot of people who actually been early testers for SBOM tool. Another thing, of course, you still want to come back to raw materials on JSON file, and I build it on two ways. You can basically have this tree representation, but you always can just push V button and get to raw JSON. And as people could see, this is great, but it's not the way how people actually reading or digesting the information. Exactly, not really human readable. Yeah, that's pretty much it. I think it is the two modes of the tool. We're currently in the view mode for the single SBOM. You can use a div when you can basically have a comparison for two different SBOMs and see the differences. It's very useful actually to kind of like see if vendors send you the new one to understand what changed. So without reverse engineering the software, and already in 5 minutes you can start asking the questions if something weird happened. So which is good. You can basically increase velocity of and speed of reaction, so taking an action on some problems. I think that's pretty much it for the demo.
Very cool, very cool. I love that you just released that a few days ago, open source. Love to see that. And I can also see that helping compliance teams. Like sometimes in the vendor review process, they send you like an SBOM, and like every year you have to renew, and like you can compare like this year's SBOM with the one they sent me last year and get the major changes. So that's actually super useful.
Exactly, or you can basically check an SBOM which is produced before buying this software and understand this is like, wait a minute, it's create me more problem than actually value.
Very cool.
All right, I think like one closing thought from my side to our audience. I think it's, if you want something to happen, you need to make a step forward and take an action. So I was waiting for this tool quite a while, and I was thinking like, no way someone will not creating this tool. But in the end, I ended up being the one, because like everybody was thinking the same way.
to go and make the tools you want to use.
Exactly.
I love
that. Yeah, we have so many problems in the industry. I creating even more. Guys, interesting times. And thank you for having me on this podcast.
Thank you so much for coming. The last question is, where can people find you online?
Oh, yeah, you can find me on Twitter. Like my handle, it's literally the same as my last name, Matrosov. So you can find me on LinkedIn, same thing. Like my last name is my handle on LinkedIn. And on the GitHub, like for the project, it's SBOM-Tools. That's literally a website. So like it contains the links on the GitHub, on documentation. By the way, the tool is built on Rust. So basically like I found the Rust super useful from the perspective of vibe coding. If you have incorrect program, it doesn't compile. It doesn't mean you will be expect all the bugs, specifically logical bugs. And it is a complete different story for different podcasts, but sometimes AI models get lazy in purpose, just like to use less tokens on prepaid subscriptions. So, and I think like also, yeah, just I think if you add me on LinkedIn, on Twitter, so happy to chat, but also feel free to send information or feature request on info@sbom.tools. And yeah, keep hacking, keep researching. It's a lot of interesting places where we didn't look much yet, and we should.
Very good. Thank you, Alex.
Thank you. Bye bye.